So as I mentioned in terms of chapter 10, and for us, we will deal with probability and counting technique. So we will do all in 10.1 through 10.4 is just the introduction of probability and the introduction of counting technique. And today, like I mentioned, we will go over 10.1 all the way to 10.4, the definition. And there are a few problems that I want to show, but we will not go in detail of the problem, okay? So in terms of probability, all of you or many of you all know this probability item or the probability or what probability represent. So, but we have some terminology we want to go over so that it's easy for us to communicate to each other, right? So the probability experiment is basically, in short, is basically what we try to do or what we try to accomplish. For instance, if I flip the coin, that is the experiment, because I don't know if the coin land on a head or a coin land on a tail. If I pick out a card, then again, that is my experiment. It's basically what we try to see that the outcome going to be. The outcome can be a head, an outcome can be a tail. If I have a dice, the dice can land on number 1, number 2, number 3, number 4, number 5, right? If I roll the dice, that will be your experiment, which is the process of you doing something that lead to the outcome. And in the experiment, we have a sample space. The sample space is basically the total possible outcome that you have. So if I flip the coin, you see that again, the sample space will be a head or a tail. If I roll a dice that have 6-sided that contain 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot, those are your sample space. Okay, so sample space is basically the total possible outcome for whatever the experiment that we want to do. And in the sample space, there are an individual outcome, meaning again, the outcome can be a head, one outcome, or a tail is the other outcome, right? So the outcome is basically the result from your experiment or in terms of the subset of your sample space. And if you remember, subset meaning a portion of a set, right? And the event, one thing in short is the event is what we are looking for. Okay, the event is when you do the experiment, you want to looking for the event. So for instance, I want to looking for a tail. What do? I flip the coin. That's my experiment. The event is what I'm looking for. I'm looking for a tail. The outcome can be a head or a tail, and that is the same as your sample space. Okay, so in short, this is what we have is the experiment is what we want to do, right? In this case, the experiment I want to do is I want to draw a card. So if for those of you who don't know the decks of cards, this is your sample space for your decks of cards, right? Meaning again, this is all of the possibility that you can get, but you only pick out a card. You only pick out one card, right? So the experiment is we pick out one card. The sample space is, this is the total sample space, the total possible card that you have, which is 52. You have the ace, which is 1, 2, 3, all the way to king, right? So jack, J, Q, K, right? Jack, queen, king. So the sample space, as you can see, if you were to dissect this, the experiment is we pick out one card. That's what we want to do. The sample space is the possible card that we have in here. And the event is we want to draw an ace, right? I want to pick out a card, and the card I want to pick out is an ace. And that's the event. That's what we're looking for. As you can see, what is the outcome? The outcome can be an ace, can be a 2, can be a 3, can be a 4, can be 5, 6, 7, 8, 9, 10, jack, queen, king, right? And again, it can be heart, can be diamond, can be spades, or can be a club, right? So basically, the definition is tell you the most important thing that I want you to remember is the event is what we're looking for. The sample space is what the total possible item we can have. And as you will see later, that's what the probability is. The probability is what we're looking for, over the sample space. Okay, if you look at this thing here, we skip to chapter 10.4. The reason is it's a little bit out of order, so I want to put in the order that I want it to be, or to teach you guys. So 10.4 is basically tell you that a tree diagram, a table, and the sample space is in short, chapter 10.4 is basically tell you that how or what is the different ways can we come up with the sample space. What is how many different way, or what is the different way that we can come up with this sample space? And if you remember, the sample space meaning what is the possibility, what is the total possible outcome that we can get. So the tree diagram, you will see this basically we try to draw like a tree to show us what we need to do. And for instance, let's say if I want to flip the coin 3 times. If I want to flip the coin 3 times, do you agree that if I flip the coin the first time, I will have a head or a tail? If I have a coin, it's either a head or a tail. If I flip the first time, I can get a head or I can get a tail. And if I flip the second time, do you agree that if I flip the second time, I can have either a head or a tail, and again, a head or a tail? Meaning, what does this mean? This means in the first try, if you look at this thing here, it's not that I flipped 4 times or 3 times now. I only flipped 2 times, ladies and gentlemen. It's basically tell me that I can have a head the first try and a head a second try, right? Or I can have a head the first try and a tail a second try, right? So this thing here meaning first I got a head, then I either have a head or a tail. And the bottom here is the first thing I have a tail, then I have a head or a tail in this case. So it's not that I flip more than 2. I only flip 2 times. It's just that the tree, or we branch it out. I branch it out to 2 different outcome, a head or a tail. And within a head, I will have either head or tail. And within a tail, I will either have a head or a tail. And if I flip the third time, I branch it out, and within this thing here, I will either have a head or a tail, and vice versa. Meaning, what does this tree diagram mean? Well, the tree diagram means this, which is I either have the first time I flip, I have a head. The second time I have a head. The third time I flip, I have a head. Or I can have a head, and a tail. Or I can have a head, tail, head, tail, tail, or vice versa, tail, head, tail, head, tail, and so on, so forth. Meaning, as you can see, this is what the tree diagram tell you. The tree diagram just show you that we start with something and we branch it out, we branch it until we finish with how many ever experiments that we want to do. Again, what is the experiment? The experiment here is we flip the coin. And again, in this case, we flip the coin 3 times, meaning each time we flip the coin, we have an experiment. Okay. And as you will see later, the total sample space that we have is 8. This is the total 8 sample space that you have, in terms of that there's no other outcome beside this 8 outcome that you have. This 8 individual outcome, or as you will see later, there's no other combination of head and tail other than this 8 head and tail. Okay, so in short, the tree diagram is basically tell you that we list out, we branch out what is the result from our experiment. Okay, the first experiment, the second experiment, the third experiment. The other thing that in 10.4 they tell you is, instead of the tree diagram, like this thing here, and again, the tree diagram can be vertical or horizontal. This thing here, I do it horizontal. Instead of a tree diagram, they can give you a table. And as you can see, the table here tell you that if you were to roll 2 dice, one of them is blue, one of them is red, this is the total possibility that the dice can land on. Again, reminder, the dice is the 1 dot, the 2 dot, the 3 dot, the 4, the 5, the 5th, and the 6th dot, right? Those dots represent by 1, 2, 3. So this is the total possible outcome that your dice, the 2 dice that you roll, can land on. It can land on 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, or vice versa, 2, 1, 2, 3, 1, 4, 1, 5, 1, 5, 6. And all of this thing here, the total possibility, as you will see, that we have 36 total possible items that can come out. Okay, and for now, we haven't done any problem related to the sample space. We just want to show you that there are different ways that we can illustrate the sample space. One way is the tree diagram. Another way is the table. In this case, we just lay out all of the possible outcome, right? And the other way is you will see that the frequency distribution table, but we will get there later. So, and that's all there is in 10.4, ladies and gentlemen. But let's go back to the key item that we have in terms of the probability. So how do we find the probability? And this is the only thing that relates to chapter 2, if you remember chapter 2. If any of you remember chapter 2, this is the only thing that relates to chapter 2 that we have is they say let E be an event. And remember, the event is a subset of a sample space, right? Which is the portion of the sample space. We will write the N of E. What is N of E? Reminder the cardinal number, right? The N of E, cardinal number of E, which is, in short, how many items is in the event. And then we write the N of S, which is the total number of items in your sample space. And this, ladies and gentlemen, to find the probability of the event, the notation we have to find the probability of the event, all you need to do is ask yourself, what is the total of the event that we're looking for over divided by the total sample space, meaning the total possible outcome. And one thing that you have to recognize, that if they ask you for probability, the answer will always be between 0 and 1. The probability will never be bigger than 1 and will never be smaller than 0. So if they ask you to find the probability and you give me 3.71, you did something wrong. Your answer should not be bigger than 1. Okay? So in short, you will hear me say a lot to my student is to find the probability of the event, whatever the event is always ask yourself, what are we looking for over the total? It will always be, what are we looking for over total? Okay. And again, each thing in the sample space have an equal likely chance to occur, equally likely can come out. Okay. So I think I have a small problem that to help you a little bit in the same of this item here. Let's say a single dice is roll, right? We have a single dice and roll, and they ask you to list the sample space and then compute the following probability. Find the probability of the dice land on number 5. On a 5, find the probability of the dice land on the number less than 5, and find the probability of the dice land on an odd number. So if you keep hearing me say that the dice, right? The dice, the sample space is 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot. And each dot represent by a number, 1, 2, 3, 4, 5, 6. So do you see that the sample space is just that? And again, we have this in raster notation, right? We list the individual item out. That's what we have in chapter 2, right? But looking at this thing here, the sample space, which is 1, 2, 3, 4, 5, 6, your element, your item is those items. So how do we find the probability of the when you roll or when you throw this dice, what is the probability of this thing land on number 5? Well, how many number 5 do we have? Do you agree that my event, I have only one? I have only one item contain number 5 out of 6 items because that is my total outcome. So the probability of this thing here is 1 out of 6, 1 over 6. Okay, so that's all that you ask yourself is, based on this sample space, how many items contain the criteria that we're looking for? How many items that contain the item that we're looking for, and over the total. So similarly, if you look at this thing here, they ask you, find the probability of land on a number less than 5. Oh, I think I did something wrong. What number is less than 5? Do you agree that this number is less than 5? This number is less than 5. This number is less than 5. This number is less than 5. So how many items fit the criteria that is less than 5? We can see that it's 4, not 5. Sorry. Let me change this. 4 out of 6. And 4 out of 6, ladies and gentlemen, 4 out of 6 is equal to, we can reduce this item to become 2 out of 3, right? We can divide this by 2. 2 going 4 is 2, and 2 going 6 is 3. We can reduce that item to that. So again, to fix this thing here, this is what we have, not 5 out of 6, but we have only 4, right? We have only 4 items that fit the description that is less than 5 out of the total item of 6. So again, to find something, to find the probability of anything, the first thing you need to ask yourself is, what are we looking for? What is the criteria we're looking for? And the criteria we're looking for, we put it on the numerator over the total. And if you divide this thing here, 2 out of 3, or 2 divided by 3, this thing will give you 0.6666667, right? This thing I think is 0.166666666. But again, on Alex, they will ask you for decimal, or if they ask you for decimal, they will tell you how many decimal they wanted, or they will ask you to put them in fraction. Similarly, looking at this item here, how many items fit the description that is an odd number? Do you agree that odd number is 1, 3, and 5? So do you agree that there are 3 items that is an odd number out of 6 items? And again, why out of 6? Because the total sample space I have is 6 items, and the item I'm looking for is 3. What am I looking for? I'm looking for the odd number, 3 odd number out of the total 6. In terms of this, 3 out of 6, reduce it to 1/2, meaning 50-50, right? I have 50%. If I roll the dice, if I roll this dice, I have 50% of get an odd number and 50% of getting an even number. Okay, so again, in short, that's what probability is. In short, all you do is you try to ask yourself, what are we looking for over the total? Okay, so let's take a look. Well, first of all, question with how to find the probability, or what's the definition of probability? Again, the other idea was just an easy, communication purpose, right? The experiment, the events is what you're looking for, and the sample space is what is the total possible item in your experiment.
Mr. Tron.
Yes.
With this being this probability, will we always have to use fractions to determine the answer, or no?
Yes.
Okay.
You always, whatever they ask you for probability will always be fraction, unless they give you the probability in decimal.
Okay, and then we would just have to convert it into a fraction.
Yes.
Oh, okay.
So it's always a portion of something, unless they tell you like if you watch the weather and they say the probability of the hurricane hit us is 0.73, right? Meaning again, they give us the 73% already, so you don't have to put in a fraction. But whatever the probability is, if they give you the raw data like this, or any raw data, will always be a fraction. Yes.
Okay.
So there are 4 facts, or there are 4 property for probability. So one thing is, like I mentioned earlier, the good thing whenever you try to find a probability is your probability will never be a negative number. Whatever you're looking for, your answer, if they ask you find the probability, find the probability, find the probability, your answer will be never, never, ever be negative, because the smallest probability that we get is 0. And if it's 0 probability, then that item, as you will see later, will never, ever occur. Okay, so the probability will never be negative. And the second thing is the probability will never be bigger than 1. The maximum percentage we have is 100%. Ladies and gentlemen, the maximum percent we have is 100%, and convert that to probability, meaning 1. The maximum that you have is 1. And if the probability is equal to 1, if the probability is equal to 1, meaning that item will guarantee to occur. That item will always occur, will always happen. Okay. The other thing is, like I mentioned, if you have 0, so this is what we have is basically in the sense of this level of certainty, right? This level of certain. If it's 0, meaning it's impossible for you to occur. Whatever your probability equals to 0, meaning it's impossible for you to have it. So like if I have a dice, right? If I have a dice and I say, if I roll a dice, what is the probability of the dice land on number 7? You say, wait a minute. The dice, the biggest number is 6. How can it land on number 7? Meaning it's impossible for it to land on number 7, right? And if it's equal to 1, meaning it will always occur. And again, anything in between, which is in the middle, which is 50-50, right? If you flip the coin and assume that they don't land on the edge, if you flip the coin, it's 50-50, right? If it's a fair coin, I should say. And again, anything be less than 50-50, it will be unlikely to occur. Anything more than 50 would be likely to occur, okay? But your answer will always be between 0 and 1. So it's either will be in decimal or in fraction. It will never be in whole number other than 1. So to answer your previous question, they will either give you a fraction or a decimal. And like I say, if they ask you to find a probability and you give me like 270, that's wrong. 270 is not a probability. It might be a total of something. You need to divide that into something or something like that, but you will never have the probability of something is equal to 100, more than 100%. Okay. And the last item is the sum of all probability. If you add all the probability together, it will be equal to 1. So again, this is just the property of probability in the sense that this thing will always occur based on our probability definition. You will never have a negative. You will never have bigger than 1. You will always, your probability will always be between 0 and 1. And you will, if you add all of your probability together, it will be equal to 1. Okay, so that's the good thing, right? That's the good thing is your answer. If they ask you to find the probability of something, then your answer will only be decimal. Okay. The next set of definition is if we have a probability of an event, which is your E. Now they turn around and they say, what is the probability of not the event? What is the probability of that event does not occur? So the complement, if you remember the complement in chapter 2, the complement is what is outside of the circle, right? You either inside the circle or outside of the circle. You either inside A or outside A. In this case, you either be an event or you not the event. And if you're not the event, which is we have apostrophe E and the or caret caret E. And to find the probability of not the event, all you do is you take 1. Why 1? Because reminder, 1 is the maximum probability we have. We take the maximum probability minus the probability of the event. and that's the complement of the event. So for instance, let's say that if you watch the weather and the weather guy say the probability of rain for tomorrow, the probability of rain for tomorrow is 45%. Well, what is the probability of not going to rain, right? If we know that 45% or 0.45, if we know that the probability of rain is 0.45, do you see that if the probability of rain is 0.45, all I need to do is take 1 minus 0.45, and that will give me 0.55, meaning the probability of not rain, right? The probability of not rain tomorrow is 0.55. So that's what the complement tell you to do is if we know the probability of the event, if we know the probability of the event, whatever the event is, if we know that probability, all we need to do is take the maximum 1 minus that probability to give me the leftover or the complement of it, not it, okay? So again, 50-50 is easy, right? But whatever, if the probability of something is 0.21, then again, not that item will be 0.79, okay? So that's the complement of the event. And now the terminology is a little bit different, but I want to tell you guys that the empirical versus the theoretical is the same probability. Well, not the same probability, but it's the same way to find it. The only thing different related to the theoretical is the theoretical is fixed. Meaning if I tell you that we have a standard dice, you say, okay, standard dice, they are 6-sided, it's fixed. If I say that we have a standard 52 card, then you say, okay, that's the deck of card is 52, it's fixed. If I say that the coin, you will say, okay, the coin have 2 faces, 1 tail, 1 head. It's fixed. Meaning theoretical, most of the item will be some fixed item. Empirical, the only thing different between empirical is now you have to go and gather your data, gather your information, gather your item. Meaning, for instance, if you want to know how many people vote in the next election, how many people are going to vote for Trump or how many people are going to vote for Biden, what can you do? Well, the only thing you can do is you can survey, right? You can only send out a letter and ask them to send back to you, or you can stand in front of Walmart or stand in front of Winn-Dixie or stay in front of whatever and ask them, do you A, vote for Trump, or B, vote for Biden in the next coming election? Which is the empirical is basically you have to go out and gather some information. But to find a probability, is the same thing, ladies and gentlemen. To find a probability is what are we looking for? What is the event that we're looking for over the total item, the total people, right? So if you survey 500 people and 250 of them say they're going to vote for Trump, well, again, what is the probability they vote for Trump? Well, 250 over 500, you can see that 50-50. Right? And that's what we have in the sense of this empirical. It's just the terminology. It's just that tell you that your data, you have to gather your data rather than it's a fixed data, rather than it's a standard fixed item, okay? But to find the probability is always what we're looking for. In this case, the frequency over the total frequency or the total people, okay? So all of this terminology, let's take a look at this item here. So, and again, I guess this is where I got the 500 people come in. But let's say if they give you this item, and this thing here is a empirical because they have, you know, this data will, the 500 people you ask might change. It's not always the same. And that's the reason why, or that's what empirical mean is, you know, this 500 people, and if you add another 500 people, the result will not be the same all the time, right? The reason why we say theoretical is because the coin is only a head or a tail. The dice is only 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot. It will never change. It's just that, right? Unless you scratch out one of the dots, but assumably it's just those dots. Or the Dexter chord is just A, 2, 3, 4, 5, and so on, meaning it's always the same all the time. Empirical meaning this 500 people, and if you add another 500 people, if you ask another 500 people, the result will not have the same result as in this 500 people. So it's changing depending on where you ask or who you ask, and that's why it's empirical. Okay, and that's the difference. But let's take a look at this thing here, and this is what they ask you is, in a random sample of 500 people, so we know that we asked 500 people, 210 of them have type O blood, 223 have type A, 51 have type B, and 16 have AB. First, set up your frequency distribution table, then use that to answer the following question. So what is the frequency distribution table? Well, the frequency distribution table is just basically you tally up and you basically create your chart. And we know that there are blood type. There are type O, type A, type B, type AB. And then the frequency is basically tell you, well, what is the number of people have type O? What is the number of people have type A and B and so on? So as you can see, if you add this number together, if you add the 210, the 223, the 51, and the 16, if you add them together, it has to be equal to the 500, right? So in the sense, it's just basically we distributive the number corresponding to the category that they give us. In this case, this is my category. So everybody see where my number come from. Basically, this is your frequency distribution in terms that you distribute the people into each category based on their survey question. And looking at this thing here, this is your empirical, because like I mentioned, if you add this, if you ask another 500 people, the result might not be distributed like this. It might be different, right? We might have more B plus type than A or something like that. But let's base on this item, and they ask you, if we were to select one person, find the probability that the person have a type O blood. So again, find the probability, just the same as before. Find the probability is what we're looking for over the total. What are we looking for? We're looking for type O. How many type O do we have? The probability of type O or O type. The probability of type O is, do you agree that I have 210 people out of what is the total people in my survey? In this sample, the total people in this survey, or the total people is 500. So that is what we have. And if you hear me say what we're looking for over the total is, that's the case, what fit the description over the total. So again, most of the time they will ask you, like I mentioned, they will ask you for decimal, and they will tell you how many decimal place they want it to be. And in this case, the decimal will be 0.42. And to be safe, you can just give me a decimal. I can go back if they mark it wrong. I can go back. But as you can see, it's not bigger than 1. Okay, and if you remember, your answer have to be between 0 and 1. So in this case, we have 0.42. If you convert to decimal, then yes, it's going to be 42%. Okay. But again, probability will always be in decimal in terms of this. So if we select one random person, find the probability of that person have type AB. AB together, not A or B, okay? Type AB blood. Again, how many people have type AB, which is in this case is 16 out of the total. Again, what am I looking for? I'm looking for the AB type. Not the A type or the B type. It's a A, B together. And again, the AB, I have 16, divide by that to give me 0.032. And the next question, find the probability that the person do not have type A blood. So type A do not have type A. Looking at this thing here, there are two ways you can do this. And do you agree that type A, we have 222 over 500. And 222 over 500 will give me 0.446, right? But if you remember, they're not asking you for type A, they ask you for not, does not have type A. And how do we find the item that does not have type A? Well, do you agree that if we have type A, all we need to do is we take 1, which is the maximum, minus 0.446. And if we do this thing here, we will get 0.554, right? Which is not type A, does not have type A, which is if we know type A, all we need to do is take 1 minus the type A to give us the other item, right? So, or if not, what else can we do? Do you agree that this is what we can do is if you want to, oh my God. You guys still with me?
Yes.